A few more miscellaneous trig questions here before we finish the unit. So here's one from, I think it's exam one. Yep, exam one. So we're going to leave the tech alone and try this one by hand. So the graphs of y equals cosine x and a sine x, where a is a real constant, have a point of intersection at x equals pi on 3. Find the values of a. All right, so if those functions intersect, they're going to be equal to each other. And we know that this occurs, or this will be true, when x is equal to pi on 3. So we're going to go cos of pi on 3 equals a sine pi on 3. All right, so here's where it's important to know your exact values. So I just know that's the cosine of 60, which is a half, equals a sine, and that's the sine of 60, which is not a half. That's the other one, which is root 3 on 2. That's going to be, if I multiply by 2 and multiply by 2, we're going to get 1 equals root 3a. Therefore, a is equal to 1 on root 3. There's no need to rationalize that, but if you saw fit to, you could write that as root 3 on 3. That's the rationalized version, but we don't have to do that. If x is an element of 0 to 2 pi, find the x coordinate of the other point of intersection. So basically, over this domain here, that is going to be one solution, and we want the other solution. Okay, so the way I'm going to do this one here is, again, write what I know, which is cosine x equals 1 on root 3 sine x. Now what I'm going to do is multiply this side by root 3. That means this side gets multiplied by root 3, and divide both sides by cosine x. Now the net result will be root 3 equals sine x over cosine x. Recognize that. That is this, equals tan x. So what I'm looking for is when tan x is equal to root 3. So let's go and have a look. So the base angle for root 3 is going to be pi on 3. That's my base angle. So it's going to be at pi on 3, and the next time it's going to be there is around here, which is 3 pi on 3 plus pi on 3, which is going to be 4 pi on 3. So we're going to say x is equal to 4 pi on 3 for the 1 mark. Okay. All right. Let's get stuck into exam 2, and now we are allowed to use this calculator. All right, we've got Trig the gardener. Yeah, I think Trig also makes another appearance in another exam, this particular person here, along with a person called, what was it again? Not Indiana Jones, it's Tasmania Jones. So Tasmania Jones was a recurring character for a number of years, although he seems to have lost his way or lost his favour with methods examiners. But if you start doing past papers, you'll know Tasmania Jones does appear from time to time. All right, working a temperature controlled greenhouse during a particular 24-hour time interval given by this function over 0 to 24. Okay, state the max temp in the greenhouse and the values of T when this occurs. Well, for the time it's going to take me to sketch this function on the calculator, I reckon I'll be able to knock together a fairly good one just quickly. Right, so our period is going to be 2 pi over pi on 8, which is 16. Our scale is going to be 4, so 4, 8, 12, 16, 20, 24. There's 16. Now it's, so again, it doesn't say to sketch it, so this here is just my rough working out. So this is not for submission of marks. You can do this as loose as you want, okay? So this is going to be 25, 27. Notice the scale's off, but it just does not matter. This is a means to an end. It's cosine, and it's a normal cosine function. So there, 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 back to 16, back down. All right, so state the maximum temperature in the greenhouse and the values of T when this occurs. Well, the max is 27. Make sure you use some context there. And this occurs at T equals 0. So there, as well as this one here, and t equals 16. Right, so state the period of the function t. Well, we've already done that. That's going to be 16, and make sure you give it some context. So 16 hours. Find the smallest value of t for which t, or capital T, equals 26. Now note that capital T is the name of the function. That's it there. So that's what we've got to base it on. Okay, so when that is equal to 26. So what I'm going to do is say 26 equals, and at the same time I'm just going to define this function here to stop me having to flick around between pages of the document. Plus 2 times cosine shift I on 8 multiplied by x. Okay, so there's my function there. So for the 2 marks for this question, I've got to write 26 equals 25 plus 2 cosine pi t on 8. And then I'm allowed to slam that into the calculator there for the solve. But it is a fairly neat solve, actually, this one here, because you see what's going to happen is it's going to come up at a half. Okay, but we're well within our rights to do this one. Not sure what's happened there with that function definition. Hey? Oh, I didn't define it. Yeah, so the thing is there, you've got to use the word define, f of x, for it to define. Okay, so now what we're going to do is say solve 26 equals f of x. So when is the function equal to 26? Over the domain 0 less than x less than 24. It's going to be a couple of times. So we're going to say that t equals, so let's do this properly, and we're going to say where t is an element from, I think, 0 to 24 according to the original definition. So t equals 8 on 3, 40 on 3, 56 on 3, therefore t is equal to 8 on 3. So that's when t is equal to 26 for the whole function, or the whole domain of the function, which is there, there, and there, so 3 times. But we want the smallest one as per the instructions in the question. So we want the smallest value of t for which it's 26. All right, for how many hours during the 24-hour time interval is t greater than or equal to 26? Again, the beauty of having this graph allows us to see some of the cool symmetry properties. All right, now notice here that this intersection between the line 26 and the function happens at 8 on 3. So that means that the distance from here to here, or this part here, is going to be 8 on 3. So I'm interested in that. And I'm also interested over here because the line is going to intersect there, and we're going to get 2 parts, one part here and one part here. Now I know it doesn't look it by the shape of my graph here because it's not to scale, but actually this part here, actually I might even do this in a different color to emphasize the point. This part here is the same as this part here and has exactly the same as this part here. So what we're looking at is actually 3 lots of this distance here, because it's going to be above 26 there and above 26 for that whole duration. So that's going to be 3 lots of 8 on 3. So to answer this one here, what I'm going to say is, it's worth 2 marks. Let me think about this one for a bit, because I know what the answer is, but I'm going to think about how I'm going to do it. Okay, so I've had to think about how I'm going to get my marks for this question. And so what I'm going to say is this. I'm going to say t is greater than 26 when t is an element 0 to 8 on 3, union with those other 2 points there, which was 40 on 3 256 on 3. That's when it's greater than it. Okay, so I think that that's enough for kind of like method or kind of understanding what's going on here. Right, so that's going to mean that I'm going to do 3 lots of that 8 on 3 distance, which 3 8s are 24 on 3, which is equal to 8. Therefore, 8 hours in context. All right, Trig is designing a garden that is to be built on flat ground. In his initial plans, he draws the graph of y equals sine x, 0 to 2 pi, all looks according to plan, and decides that the garden beds will have the shape of the shaded regions shown in the diagram below. He includes a garden path which is shown as line segment PC. This is the garden path. The line through the points there and C is a tangent to the graph at point P. So this line here is a tangent to this graph. All right, that's going to be important. All right, find dy dx when x is equal to 2 pi on 3. Okay, so dy dx in this case is equal to, the function was sine x, I believe, yes. So the derivative of sine x is cosine x. And then what we're going to do is dy dx with x is equal to 2 pi on 3. And that's equal to cosine of 2 pi on 3, which is equal to, so there's pi on 3 there, and the cosine of pi on 3 is a half. So this one here is going to be 2 pi on 3, so it's going to be negative a half. So the rate of change when x is equal to 2 pi on 3 is negative a half. Show that the value of c is root 3 plus 2 pi on 3. All right, so what was c again? C is this thing here. Now that is the coordinate of, or the x-ordinate of the x-intercept of the tangent. All right, so here's what we're going to do here. All right, so we're going to work out the equation of the tangent. Now the way we're going to do that is we're going to note that we use this formula here, y take y1 equals m x take x1, just a transposed version of the gradient formula, m equals y2 take y1 over x2 take x1. Now, what it needs is a gradient, and thank you very much. Part 1 gets us to work out the gradient of the tangent when x is equal to 2 pi on 3, or at the point where that tangent hit the graph. So again, very rarely in methods is there like a question just for the sake of the question. So notice here you find this and it's like, why did they choose 2 pi on 3? Like, why didn't they choose any other points? Well, there's a reason for it. So this is our m value over here. So what I'm going to do is note that this is going to be y take. Now our y value at that point is root 3 on 2. Negative a half is our m. X take, I think it's 2 pi on 3 is our x value. All right, so what we're going to do is now make x the subject of this, okay? So what we're going to say is the x int occurs when y equals 0, because that's really what I'm after, the x-intercept of this linear function. So I'm going to go and say 0 take away root 3 on 2 equals negative 1 x take 2 pi on 3. Okay, so my working is a little bit all over the place here, but I'm going to swing my working out over to this spot here, and I'm going to say that I'm just going to expand this out. That's what I'm going to do next. That's going to be negative root 3 on 2 equals negative x on 2, take plus rather. 2's are going to cancel each other out, plus pi on 3. All right, so now what I'm going to do is go and say negative root 3 on 2, take pi on 3 equals negative x on 2. All right, I'm going to drop all those negatives. So I'm going to say root 3 take plus pi on 3 equals x on 2. Now I'm going to multiply by 2. X is equal to 2 root 3. Whoops, I forgot to put it over 2, which is going to mean that it's just root 3. Yep, so don't know why I dropped that root 2 there, that 2 there, so make sure that goes in there. That means that when it's multiplied by 2, is just going to be root 3. And this one is going to be plus 2 pi on 3. Now, that's what I was trying to indicate. So I've said that x equals that, therefore c equals root 3 plus 2 pi on 3 as required. All right, now getting a bit tricky, and it certainly does do this in exam 2. So don't forget, girls, that the questions aren't necessarily in order of difficulty, but each question goes from easiest part to hardest part. And even last year, girls, there was a question on question 1 in exam 2 that actually the state got, I think, like 5 or 10% in. Okay, it was the toughest question on the paper, I think, or the equal toughest question on the paper came in question 1 in the latter part of it. So don't forget that even in question 1, don't be demoralized if you're doing exam 2s and you think, wow, this last part of exam 1, I can't even answer that. That's just pretty normal, so don't fret about that. All right, I'm beating around the bush here. In further planning for the garden, Trig uses a transformation of the plane defined as a dilation of factor k from the x-axis and a dilation factor m from the y-axis. K and m are positive real numbers. So these are the image points under the transformation of the original points. So we've got like x and x dash p and p dash and c dash. They're going to be the new coordinates. So find the values of k and m if x dash p dash equals 10. Now, important to note that this notation, I see this more commonly written as line xp. So that basically means that after the transformation, the length of this line is going to be 10 xp. Let's have a look at it originally. There it is there, it's xp, okay, and its current length is actually root 3 on 2, and it's going to end up at, so that's like 1.7 divided by 2 is like, what is it, like 13 or 14.5, 13.5 or something like that. What am I saying, 13.5? 1.35. No. What am I doing? 1.7, 17, it's like 0.6 or 0.7, all right? It's going to jump all the way up to 10. So this will be x dash and p dash, the new value here, will be there, okay? And so what we're looking at here, or what we're interested in doing to answer this question, we're saying root 3 on 2 multiplied by a particular value is going to equal 10, okay? Now let's go back down here and see what we're doing here. So I know that in this case here, I've got dilation k from the x-axis. So it's going to be that, I'm going to have to scroll here a bit, girls, my apologies. So this value here, this y value, root 3 on 2. So root 3 on 2 gets multiplied by this dilation factor k, and we need it to equal 10, i.e. this is basically saying what would root 3 on 2 be dilated by to make the length of the line, or the new line after the transformation, equal to 10. So what we're going to do is multiply it by 2 and divide it by root 3. So k is going to equal 20 on root 3. And we've found out our first value there, that's the k value. All right, the other one is 30. That's x dash c dash, or line x dash c dash. So this is the original one, xc, that's that line there. And what we're interested in is what it becomes, because it's going to get pushed out somewhere. I don't know how far, I wouldn't have, oh, it says 30 actually. So that length there is going to be 30 after the transformation. Now, what we're interested in, to use the same approach as last time, is to do exactly the same thing, okay? So what we're going to do is work out basically what this original length is here. And the original length is actually going to be this coordinate here, this C value here, take away this value here. So essentially what we've got by this C value here is the length of this line here. We only want the length of this line here, so we need to remove this. Now we do know the length of that. That line there is 2 pi on 3. Okay, so we know the length of this line here. And we also know this C coordinate here because we worked that out in a previous question. So we found out in this question here that C was equal to root 3 plus 2 pi on 3. So we're going to say that root 3 plus 2 pi on 3 take away, so that's the x value there, that's the x value, and we're going to remove 2 pi on 3 from it, take away 2 pi on 3. When I've done this, this value here is multiplied by this m value here, this transformation, this dilation factor m from the y-axis, so it's going to be m, and that needs to equal 30. So what are we doing here? This is going to cancel out. Now I've got root 3 times m equals 30. M equals 30 on root 3. Again, you could rationalize that if you wanted, but there's no point in my mind doing that. If you stuff up the rationalize, you lose the mark for it. Okay, so find the coordinates of the point P, all right, or point P dash. So what was P originally? P was 2 pi on 3, comma, root 3 on 2. So let's note that P was 2 pi on 3, root 3 on 2. Again, my apologies here, I just want to double check that value. 2 pi on 3, comma, root 3 on 2. All right, all good. And now what happens is, so this factor here, that's the dilation factor K from the x-axis. Okay, so what we're going to note is when we dilate by a factor of K from the x-axis, we will, what are we doing? We're going to multiply the y value. So P dash is going to be root 3 on 2 multiplied by 20 on root 3. So that's going to be that coordinate. And this coordinate here is going to get multiplied by this m value here. The m value is a dilation factor m from the y-axis, which changes the x value. So we're going 2 pi on 3 multiplied by this m value, which is 30 on root 3. All right, let's tidy up a little bit. P dash equals, so 110, that's going to be 20 pi on root 3, comma, 1. This should equal 10, I'm thinking. Yes, of course it should. 10. Right, so there's the new coordinate. So the y value has to equal 10. The x coordinate will be the one that changes or is a little bit less recognizable based on that transformation. Right, so P dash is equal to 20 pi on root 3, comma 10. All right, and there is the questions there to wrap up the topic. It's not as bad as it looks, okay? These exercises here have precious few trig function questions, so note that that's not an insane amount of work. But as usual, Cambridge's chapter reviews are long and have plenty of detail to it. So good luck with that.